Hello, good afternoon. My name is Cécile Maisonneuve and I'm going to moderate this roundtable. So I will moderate in English and in advance I apologize to this British audience and neighbors for my French accent. Just for the anecdote, yesterday we had our annual conference at the Center for Energy at IFRI in Brussels. And we launched the worst English accent. And I must say, I didn't win, and I won't tell the name of the winner, but I did participate, so thank you for your benevolence. I will start this roundtable by a quote I found when preparing it in a Delphi paper from the London-based IISS, saying, quote, "Between the inadequate, the impossible and the incredible, the idea of Anglo-French nuclear cooperation will still offer obvious attractions." So this was written in 1971, and it proved wrong, obviously, because the idea has turned into reality and obvious attractions has ended in real matches. I even heard the name of marriages in the previous roundtable. So this is particularly true in the fuel cycle, and this has been true for decades. And we will focus in this roundtable on the back end, and especially on the management of plutonium in the long term, because it's obviously a shared concern. And this is all the more relevant after the consultation in the UK about this long-term management of plutonium, and before the date of 2018, when the UK moved from the closed fuel cycle to the open fuel cycle. So to tackle this issue, we have 4 distinguished speakers, and obviously I will start with you, Clive Nixon, from NDA, to what I would call set up the scene. So just to give this audience a brief view on your career, you are currently the head of strategy for the British NDA, and you've been working for 15 years in different roles on R&D, technical and commercial areas as a Sellafield plant, and you're specifically in charge of you're the program manager for plutonium and spent fuel management. So, as I said, what I would like, Clive, is for you to set the scenes and especially explain us what is at stake, who are the players, and what the current situation is in what will obviously be a long, long story. Thank you, Clive.
Good afternoon, everybody. I wanted to just start off introducing sort of 2 key things to begin with. One, to ensure that you understand what the Nuclear Decommissioning Authority is tasked to do. And 2, really to give an overview of the current strategy for managing spent fuel in the UK, and also the plutonium question that Cecile's just raised there. So the Nuclear Decommissioning Authority is about to celebrate its 10th birthday. So it was set up in 2005 and has a responsibility for managing the effective and efficient clean-up of all the civil nuclear sites in the UK. So this includes the first generation Magnox reactors, the various research and fuel facilities in the UK, and our largest and most complex site, Sellafield, of which the analogue is, I guess, Le Hague in France. As well as cleaning up those sites, which probably will take up to 100 years and cost in excess of £50 billion, we're also tasked with implementing government policy on higher activity radioactive waste, and for that we mean deep geological disposal and also low-level waste. Our main contact with new build, and most of the sessions today have been on new build, is we do provide some oversight to government and provide advice on decommissioning plans for things such as Hinkley Point C. And we have, for instance, scrutinised the funded decommissioning programmes and the waste transfer contracts for those schemes. So the NDA is there to tidy up, if you will, the legacy that's been generated over around 60 or 70 years. And we've still got probably quite a long way to go. We're probably less than half the way through the journey. In terms of some of the key things, we have some high risk and high hazard facilities that we must deal with that are urgent and important. And also we inherited through the restructuring the reprocessing facilities at Sellafield and also the plutonium stockpile that had been generated over a number of years. So many of you will be aware that the UK has been doing large-scale reprocessing for over 50 years in a number of facilities, and we've dealt with large quantities of metallic Magnox fuel, and also oxide fuel. Over the next 5 years, the UK plans to cease operations in these bulk reprocessing facilities once all the bulk Magnox fuel has been reprocessed and once we've completed our contractual commitments on oxide fuel in Thorpe. Further arisings that are coming out of reactors that are still operating in the UK will be stored pending disposal, as will arisings in Sizewell B. And I think people are aware that spent fuel from the planned new nuclear reactors in the UK is currently assumed to be disposed of ultimately, so no reprocessing of that. So consequently, as Cécile pointed out, we are transitioning from one fuel cycle to another in a way. The implementation of the bulk reprocessing policy I've just outlined has resulted in us having a significant stockpile of separated plutonium, which at the end of those plans will be around 120 tonnes of UK-owned and around 20 tonnes of Japanese-owned plutonium. We've generated that plutonium without having a firm policy for its management since around the 1990s when we cancelled the fast reactor programme. So we have quite a large issue, I think, that we're obviously trying to deal with right now. So I did mention the stockpile that we had of UK material, but in addition, through reprocessing of overseas fuels, we've also got significant quantities of Japanese and some European material. And the plan was originally to repatriate that material through something called the Sellafield MOX plant, a plant equivalent to Melox. But unfortunately, due to a number of circumstances and poor operational performance, that facility was closed in 2011. So therefore, there is some material that, as well as the UK material, must be managed in the UK alongside our own material. I think everyone is happy to a degree that the stockpile is being safely and securely stored. But the strategy is costly and it's not a full life cycle solution. And the current plans show us storing that material for around 100 years. Over the last few years, therefore, the Department of Energy and Climate Change, which is our sponsoring UK government department, and the NDA have been developing our policy and developing our strategy options, focusing on reuse and immobilisation. As Cécile pointed out, in 2011 there was quite an important piece of publication that went out where DEC announced that its preliminary preferred option was to reuse the vast majority of the stockpile as MOX in the planned new reactors in the UK. However, DEC at that time said they were still open to further alternatives, given that there wasn't enough confidence at that time to go into implementation. One of the key uncertainties was around the extent and the timing of when new build capability would arrive in terms of LWR reactors. I think that position was quite wise, looking back 4 years and seeing where the programme now is for new build reactors. So NDA since that time has continued to develop the options and has went to market to request parties who are interested in looking at alternatives, as well as MOX, and Candu Energy and GE Hitachi responded to our request. Candu proposing reuse in an EC6 reactor using CanMOX, and PRISM being proposed by GE Hitachi, which is a sodium metal fuel fast reactor. After that request, NDA subsequently engaged those two companies, and as well as continuing work with Areva, who have been focusing on the MOX option, we've progressed over the last few years, developing and understanding the proposals much better. We worked for around a year and a half, and in January 2014, NDA published a position paper, which you can readily get off the internet. If you haven't, you should go and do it now, which describes the work that we'd done and the next steps that we saw going forward. In summary, that work said that all the three reuse options that we considered were credible against the definitions, and the definitions was around implementation in around a period of 25 years to commence. But we noted that all the technologies had some pros and some cons, and there was likely that there was no perfect solution. And it may be that there was a multi-track approach which offered better value for money. We were very keen to engage industry in this exercise, so it's not an R&D exercise for us. We were very keen for commercial companies to come forward with solutions. And subsequently, on the back of that, we decided to undertake some further work over around the last year or so with the technology suppliers to work out what the art of the possible was, what the key risks and uncertainties were, and also look at potential commercial implementation schemes. I think you've got to bear in mind that NDA, because we're a liabilities management organisation, is very much focused on outcomes, and we are technology neutral. We're interested in putting the plutonium, the vast majority of it, beyond reach in a cost-effective way. So over the last year, we've worked very closely with all those three parties under contract, and we've also been utilising NNL as support for that to help us with that. I think we all reflect that the reuse options are different, even though they all reuse the material, and therefore we've had to tailor the work scopes with each of the organisations. Scope with Areva, which I think is a fundamental focus of this group perhaps, who Areva are advocating the MOX route, we focus particularly on technical aspects, such as how much of our stockpile can be utilised, the licensing approach and the risks associated with that. So we've undertaken what we describe as a pre-GDA exercise. And also we've been focusing on revised cost estimates. Everything in nuclear, certainly in my estate, seems to have gone up recently rather than gone down in cost, even for the same scope. We've also investigated commercial structures and financial structures and how we can use those and the potential to introduce private sector investment to deliver better outcomes. The key area we've been working on together and continue to work on is around implementation of how and when to secure offtake for MOX in new build reactors in the UK. You've heard this morning, I think, the plans for the new build reactors and that they're still uncertain in terms of overall extent of fleets, types of reactors to be deployed and the timetable for those. So that's a key issue for us to consider, and I think that's the prime condition for MOX, particularly where we would consider the MOX reuse to be implementable on an industrial scale. So we're about to finish the current phase of work, and the outputs of the work that we've done with Areva are being considered alongside the new information we've received from all the parties. And in due course, NDA will provide our advice to DEC and UK government more broadly, so we can enable the next steps to be properly established. This year is an interesting year in the UK, given we have an election emerging, and we have to manage the decision-making across that window. So at this time, it's not possible to define exactly how or when any subsequent acquisition or a procurement process will take place, but we anticipate we'll be able to share our further progress as we go through this. But I can't really be drawn on any further details around acquisition and procurement. So plutonium is a hard problem for us. We think it's going to take a number of decades to actually implement a full solution, and I think the parties sat around the stage on today, and the links between the UK and the French are very important, particularly to ensure we understand if and when the MOX option is implementable.
Thank you, Clive. So I will turn now to you, Fiona, as Clive mentioned the role of NNL in the process, and you're indeed Director for Fuel Cycle Solution within the NNL. And you've worked across many aspects of the fuel cycles, from fuel development to spent fuel and waste management over a number of years, especially at strategic level. So, Fiona, seen from NNL, how would you describe the present situation, and especially as we here to discuss possible cooperation between France and the UK? What is your assessment about this? Thank you.
Okay, thank you. And first I should say, please don't ever apologise for accents. Your accent's brilliant, and when I can speak French the way that you can speak English, then we can comment on these things. So basically, just taking things back a step, the UK has a legacy decommissioning programme, as well as an existing operations programme for current energy generation, as well as a new nuclear build programme, taking us back to the renaissance of 16 gigawatts electrical, as well as a potential expansion programme going beyond 16 gigawatts electrical at some point in the future. And it's really useful to take all that into context, because that's quite a lot, just in terms of what the UK is actually trying to achieve right now. Now, we've been operating a closed fuel cycle for decades in the UK, with the Mackinac reactors and also with the more recent advanced gas reactors run by EDF Energy. But we're going to be moving to an open fuel cycle sometime around 2018. We probably will still need to look at how we keep future options open, though, in terms of fuel cycles in the future, depending on what the the expansion programme might look like in terms of nuclear power going forward in the future and the sort of demands that may be placed on nuclear power within the UK. And you'll hear more about that later on in the next panel. Within the NNL, of course, we support all of these programmes. So we are supporting the legacy clean-up, we're supporting the ongoing operations, the plant lifetime extension programmes that are currently happening. We're supporting the new build programme, and we're also involved in future expansion scenarios. Now, part of that is about plutonium management, and there's a significant R&D programme currently in place relating to plutonium management and UK plutonium disposition, which has been going on for a number of years. And it basically is around supporting both the UK plutonium disposition programme, but also supporting international endeavours in terms of understanding various aspects associated with plutonium behaviour and how it operates when it's either in an immobilised matrix, in a storage environment, or in a repository environment, or how it's going to behave as a fuel. If you actually look at just the UK programme associated with plutonium management, as Clive's highlighted, there are a number of options that are being evaluated at the moment. And first and foremost, the reference case is plutonium in MOX, and that's a 10% plutonium in MOX fuel, specifically for LWRs, and that's, of course, Areva, who's leading on that with the NDA. And we support both the NDA and are also working with Areva in terms of how that programme might manifest itself going forward. Of course, with that, there's also the use of plutonium within fast reactors as a MOX fuel. And there are a number of people here in this room probably who know an awful lot more about that based on the work that they've been doing with CIA going forward in terms of the whole concept of the Astrid fast reactor and the fuel to support that. As Clive's highlighted, we're also looking at plutonium as a metal fuel and working with organisations like GE Hitachi in terms of taking that forward. And finally, looking at immobilisation of plutonium in some sort of immobilised matrix, like a ceramic. So actually looking at all options. And our role within the NNL is really just to underpin a number of these options, or at least understand where the gaps might be in terms of that underpinning. And therefore, what is the technical maturity surrounding a particular option, and what else needs to be done in terms of closing these gaps to enable that option to be viable in the future. A key part of that is actually about integrating skills, capabilities, nuclear facilities, actually in support of these activities. And in order to do that, with the current economic climate the way it is, the only real way of doing that is through international collaboration. And that's a key thing that we're doing within the National Nuclear Laboratory in terms of driving that. And basically, thinking about that and thinking about how you take that forward, another key aspect is actually the generation of the new future, next generation subject matter experts, or thought leaders, as some people call them, in terms of how we actually drive that forward. And to do that, you need to have the sort of academic with the industry and the national lab partnerships at a national and at an international level to ensure that these skills and capabilities are actually here for now and also in the future. The way that we do that is actually by looking at what we can do in terms of UK nuclear and what can be done broader across other environments, but also looking at other industries. And in terms of plutonium management and actually ensuring that we maintain skills, one of the things that we're doing at the moment, which I was speaking to some colleagues about last night, was actually looking at how to maintain plutonium skills through being involved in the space programme. And that's a kind of interesting one, and it's actually an interesting one because we've managed to recruit a few people because they're very interested in the space programme. And what we've actually, you might ask the question, what is she talking about? Well, what we've actually done there, we recognise that we've been storing quite a lot of plutonium on the Sellafield site for a number of years. And it just so happens that a daughter product of plutonium, when it sits around for a while, is americium, americium-241. And there's quite a lot of that actually is sitting around with this plutonium. What we recognised was that if you harness the energy in that americium and separate it from the plutonium, it could actually be used as a radioisotope thermal generator, a battery for space. So that's one of the things we're doing. So we're doing that for the European Space Agency and working with them on that. We've managed to separate out the americium. So we're talking to the NDA now around the fact that we might actually have a more pure plutonium that we can maybe give back to them in the one hand. On the other hand, we've got something that was a liability that could be an asset that could be sold in the future. And in addition to that, we've actually managed to maintain some skills and capabilities in terms of plutonium separation and chemistry. So a bit of a win-win there. So that's one of the things I really would encourage that we have to do. We have to reach out into other industries and other opportunities to see how we can actually maintain skills and capabilities, but also bring in more business at the same time. The other thing I would just say is that there are many synergies that actually exist between the French and the UK fuel cycles. Within the UK, we've operated a closed fuel cycle for a number of years. We've operated 2 or 3 separate reprocessing facilities. We've looked at how you separate out plutonium and uranium. We understand how these materials behave over time. We've done a lot in terms of waste management and decommissioning over the years, and the French have too, you all have too. And so I think there's a lot of synergies there that we can collectively actually look at from a technical perspective and actually look at how we can actually work better together at basically helping each other out, but also how we can help out emerging nations who maybe don't have these capabilities at this moment in time. One of the examples I would give is actually just even looking at UK and French nuclear energy scenarios and actually understanding some of the fuel cycle implications associated with certain levels of energy demand. Going down that route could actually help look at some of the decisions that might need to be made in terms of approaches on R&D, looking at nuclear facility investment, even from a sort of operational perspective in terms of operating facilities and how that might actually manifest itself, taking it even all the way to combined nuclear programs. So all in all, I think there's a lot to go at here. I think the problem will be actually working out what the priority areas are and who's going to lead on what.
Thank you very much, Fiona. Thank you especially for showing our intertwined legacy from the past, current operations and future projects are. And in a way, we could say that in this country we speak about energy transition, but what I understand in the nuclear landscape in the UK, there is this double transition in the reactors, in the fuel cycle, and this is certainly what makes this landscape particularly fascinating. So I now propose we cross the channel and come to the French perception of this question of plutonium management. And I turn to you, Bernard Boullis. You are currently Director for Fuel Cycle and Waste Management at CA. So when you hear this view from the UK, what is your assessment of this question of plutonium management and of possible cooperation with the UK?
Thank you. Good afternoon. Before coming to France-UK possible cooperation in such an assessment, I would like to give a few words about fuel cycle backend and plutonium management options from a research body point of view. That is to say, maybe with a mix of ambition and humility. CA in the backend field tries both to answer the needs of the current industry, adaptation and improvement needs, and to explore, to prepare future possible options for the future. And this must not be opposed. So this has been said this morning. Both are necessary, and I think it gives opportunity for efficient synergies. So I would like to highlight 4 short points about plutonium management. First, maybe tourism. When thinking to options choice for used fuel and for plutonium management, it's very important not to omit long-term stakes. Many options are possible, and many can be seen as relevant options. But when choosing one option, it will be regrettable, to my point of view, to cancel tomorrow's potentialities by considering only short-term stakes, quite justified but not exclusive. For instance, immobilizing plutonium in a dedicated matrix, either glass or ceramic, is surely a perfectly safe management. But it prevents taking advantage in the future of its energetic value. Addressing long-term, it's by essence entering in the uncertain world. This points to my opinion the attractiveness of open and robust options, options which do not preempt future decisions, as future context could be very different as what we can foresee today. My second point will be about our vision of what long-term perspective could be in a long-lasting nuclear option perspective. To us, CA, long-lasting nuclear options are mandatory recycling options. They provide safe and well-mastered plutonium management while taking advantage of the huge potential it represents. And this, more and more, our recycling is operated in a recurrent way. This is the reason of our interest into advanced systems, so-called Generation 4 systems, with some fast neutron reactors for part of the fleet, which could provide plutonium stockpile stabilization, a drastic increase of natural uranium use, and final waste amount decrease. I would like to recall that the energy potential of identified conventional uranium reserves in the world, if well managed, that is to say by a recurrent recycle, to take advantage of the whole energetic value of this uranium, this represents one of the biggest energy sources in the Earth, far higher than joint oil, coal and gas identified reserves. I think one has to be careful before deciding to neglect such a huge potential. My third point, third message, to my opinion, very important. Keep realistic and keep pragmatic. To me, it's essential not to shoot ahead by trying to reach too fast the very final goal we have identified. We do think that a progressive approach, moving step by step towards more and more sustainable systems, could be a relevant and efficient route. Not too fast, but also not too late. It is essential too, not to wait for idle solutions before doing something, and try to take advantage as soon as possible of available technologies. I think we have to keep in mind some data. On one hand, more than 250,000 tons of used fuel unloaded from nuclear power plants all around the world. More than 2,000 tons plutonium inside. This increasing each year. 7,000 tons used fuel, so 70 tons plutonium more each year. And on the other hand, the most modern reprocessing plants we know are able to manage about 1,000 or 2,000 tons used fuel per year. So if the final goal is to take advantage of plutonium, I think we have to think to that soon enough. Otherwise, we could be overwhelmed. Current recycling operations in France, in the French fleet, already provide significant benefits, uranium savings, waste without plutonium. Sure, it's not perfect. We can expect better for the future. And improvements will come in the next steps. And the route now is open for that, with already a first significant milestone. And we are currently working both with our EDF and Areva to explore the possible next steps for the coming decades. What improvements, for what cost, and for what benefits, concerning waste, concerning resource utilization. We will report that this year to the French government, and notably how Generation 4 fast reactors could be implemented in the French fleet, once again, in a very, very progressive way. My fourth and last point, the international dimension of back-end issues is real, and it could be enlarged and could offer opportunities for efficient cooperation. A lot of things can be shared. A strategic vision first. Sustainable nuclear energy stakes go beyond each country's frontiers. The merits of diverse options, R&D, and from an industrial point of view, maybe a better share of charges and a better management of risks in a regional approach. A few examples. R&D investments required to address future advanced fuel cycle needs are very heavy and should be shared. Fuel cycle here has not to be considered alone, but embedded, I think, in a global approach with all reactor technologies able to take the best advantage of recycled materials. I think that is the spirit, this is the spirit of Gen 4 International Forum. Think globally, share visions, share goals, share standards, and also research. Another point I would like to mention, time constants in nuclear industry are very long, with heavy uncertainties, so heavy risks, technical risks, but also political risks. An international, regional approach should maybe provide more flexibility, more robustness to face such risks and to face possible changes in one country's policy, nuclear policy. So I think that all of that can be analyzed with possibly significant benefit between France and UK. Two European countries with sure differences, with specificities due to proper history, due to some particular issues, plutonium stockpiles. But two European countries which both show today ambitious views for nuclear energy. And beyond possible interest for their respective nuclear fleets, French and UK, preparing together attractive solutions for the back end, I think to advanced recycling options. This could be a way to address also some important international markets, and I think notably to Asia.
Thank you very much, Bernard. Thank you also for opening on this international aspect. So when we talk about plutonium management, we talk about strategy, we talk about R&D, and we talk obviously about industrial operations. So I think it's important to have the point of view of the industry, and I turn for this to Dominique Maucly. Dominique, you're the head of development of Areva in Asia and in the UK, and you previously were senior executive VP in Areva for the back-end business group. So the back-end issue in the UK is well known to you, as Areva is already operating there. But what I would like to know is what is your view as an industrial on this possible cooperation about plutonium management?
Merci de cette question. Alors l'avantage quand on passe le dernier, c'est qu'en fait il y a plein de choses qui ont déjà été dites. Et c'est plus simple pour expliquer ce que je voulais vous dire aujourd'hui, et en particulier comment on passe du back-end au développement du Royaume-Uni et de l'Asie. Alors je pense que quand on a écouté Fiona, quand on a écouté la table ronde précédente, en fait on a compris. On a compris en fait qu'il y a plein de synergies qui existent entre la France et le Royaume-Uni, et que ces synergies, on est en train de les développer dans le domaine des réacteurs, mais que ça fait longtemps qu'on les développe dans le back-end. On a aussi compris qu'entre nos deux pays, sur toute la chaîne du nucléaire, on a partagé des expériences, j'ai envie de dire, qui ont commencé au Royaume-Uni, et du coup, quand on est nous à Sellafield, on apprend plein de choses, qui sont ensuite développées en France, etc. Mais autour de tout ça, on a plein de choses à faire ensemble. Donc la première vue de l'industrie, et moi je suis très fier que dans la réorganisation d'Areva, Areva ait mis à son comité exécutif quelqu'un qui s'occupe du Royaume-Uni spécialement. Parce que pour moi, l'enjeu, il est en France, mais il est aussi au Royaume-Uni. Et quand on aura réussi les choses qu'on est en train de faire, comme on le disait tout à l'heure, on pourra montrer une face unique, et une face qui maîtrise tous les éléments de la chaîne du nucléaire. Dans cette chaîne du nucléaire, il y a en particulier la fin de la chaîne. On dit la fin de la chaîne, mais ça peut être le début, parce qu'il y a aussi, dans le plutonium, comme on l'a dit, plein d'énergie. Mais dans la fin de la chaîne, il y a les wastes et la gestion des wastes. Et au travers de ce qu'on fait depuis un certain nombre d'années en France et à Sellafield, la gestion de tous ces wastes, c'est une des clés. On est un peu en laboratoire, en France et au Royaume-Uni, mais du coup, on a, sur cette capacité à traiter ce que l'on a à faire aujourd'hui, on a la capacité à innover, à proposer des solutions à l'extérieur de nos pays, et j'espère qu'on va pouvoir rebondir là-dessus. Alors qu'est-ce que ça veut dire aussi de s'occuper du Royaume-Uni quand on est Areva ? Ça veut dire aussi refonder la relation qu'on a avec l'ensemble de la supply chain britannique et de la supply chain française. Et donc on a prévu d'organiser, si je prends un exemple tout simple, les démantèlements, des choses dont on ne parlait pas beaucoup. On a souvent une supply chain française puis une supply chain britannique, et il se trouve qu'en fait les deux sont très bonnes. Et donc on a prévu d'organiser prochainement une rencontre entre les gens qui fournissent les services au Royaume-Uni, et de l'organiser en France pour nous permettre à nous de relever nos défis, qui sont les défis des démantèlements de nos grosses installations. Parce que dans ce domaine-là aussi, si on veut être bon, il faut qu'on travaille ensemble pour réduire nos coûts, pour améliorer la vitesse à laquelle on traite les problèmes, et puis pour prendre le meilleur de ce qu'il y a d'un côté comme de l'autre. Alors si on parle du meilleur de ce qu'il y a d'un côté comme de l'autre, eh bien ensemble, on doit pouvoir traiter les problématiques de plutonium. Les problématiques de plutonium qui sont aujourd'hui au Royaume-Uni, mais dans le cadre du développement, bien évidemment, et ce que j'ai compris, c'est que le Royaume-Uni voulait effectivement réutiliser le plutonium pour en faire un asset, et non pas quelque chose qui reste sur étagère ou qui devient un waste à traiter, et donc de re-rentrer ce plutonium dans des chaînes normales de fabrication d'énergie au travers des combustibles qui sont des combustibles MOX. Donc on travaille effectivement depuis de nombreuses années, et on va continuer de travailler parce que c'est une des clés du développement du nucléaire aussi bien au Royaume-Uni comme en France, que de savoir traiter les combustibles usés, de savoir traiter les matières qui en résultent. Donc on continue d'avancer avec la NDA, NNL, sur des solutions de fabrication de MOX dans le cadre de coopérations qui s'étendront non seulement à la coopération industrielle, mais bien évidemment à la coopération commerciale pour fournir ce combustible MOX aux opérateurs qui vont construire les réacteurs dans le futur. Alors l'avantage du MOX, il est connu depuis longtemps, en particulier quelle que soit la solution de réacteur qui pourrait être choisie au Royaume-Uni. Ça s'appliquerait aussi bien à des réacteurs bouillants ou à des réacteurs pressurisés. Il n'y a pas de barrière, entre guillemets, à l'utilisation de cette énergie ou de ce matériau pour produire de l'énergie demain. Donc nous sommes dans des phases qui sont des phases préliminaires, bien évidemment. L'idée est de faire des choses pragmatiques, fondées sur ce qui existe, sur un outil industriel qu'on connaît, qu'on maîtrise, et donc non plus de ne pas faire courir de risques fous pour le futur et de construire sur ces choses-là qui existent. Alors vous avez dit tout à l'heure, la recherche est importante. On a pensé aussi, et je vais profiter d'être là aujourd'hui, on a pensé que les académiques, les jeunes, C'est important pour le rapprochement de nos cultures, de notre culture dans le nucléaire, et puis pour nous aider à régler nos problèmes. Alors je profite du fait que je suis là avec vous aujourd'hui pour vous dire que, à l'initiative de Rolls-Royce, Areva et EDF British Energy, on va lancer un contest qu'on va appeler le Spark Contest. Ce Spark Contest, il vise à faire travailler des jeunes. Quand on dit des jeunes, c'est moins de 28 ans, qu'ils soient étudiants ou en service déjà dans nos laboratoires ou dans notre industrie, sur les problématiques d'énergie, sous la forme simplement de... On donne chaque année une problématique et puis les jeunes y réfléchissent et puis ensuite il y a un jury qui l'évalue et puis bien évidemment il y aura des prix. Et on voulait profiter de cet événement pour dire qu'on allait le lancer cette année sur les problématiques nucléaires pour nous aider à résoudre toutes les questions ou essayer d'imaginer, au travers de ce que chacun va pouvoir penser, comment on peut améliorer la durabilité du nucléaire. Donc cette année, on va lancer ça avec des partenaires industriels, avec des partenaires universitaires. On va aussi le faire sous le sponsorship des 2 ambassades. Et le thème, ce sera The Nuclear Fuel Cycle in 2040, The Challenges and Solutions to Achieve Sustainable Nuclear Generation in Europe. Parce qu'on est pragmatique aujourd'hui, mais on n'a pas toutes les solutions. Et on pense que c'est aux jeunes générations de nous amener le maximum d'idées. Voilà, donc on le lance aujourd'hui, on va prendre et réunir tous les partenaires dans les semaines qui viennent, et puis dans un an, on organisera la remise du prix de façon un peu formelle. Merci.
Merci Dominique. Alors, rendez-vous dans un an. There is one word you use and you didn't translate in French, it's asset. So I would like to come back to this word because I heard asset, but I also heard the word legacy. So and I also heard the word hard problem about plutonium. So I would like to ask you, Clive. Bernard especially insisted on this energetic value of plutonium. And among the options you mentioned, so we understood well that you are technology neutral. Most are based on reusing plutonium for its energetic value. And as your role as NDA is also about cost effectiveness, as you pointed it out, if this energetic value is acknowledged for, does it mean there is also an assessment of the economic value of the plutonium?
Yes, when we're looking at life cycle costings, we take account of obviously the costs and any potential revenues or incomes associated with each of the options that we look at. We're looking at both immobilisation followed by disposal, as well as reuse. But in immobilisation followed by disposal, clearly there's no potential for any revenue or any energetic value being drawn from that. When we're looking at reuse, one can value the material in many ways. Overall, we still see the cost of dealing with plutonium as being a cost, so a net cost. So whilst there will be some revenues accruing, our latest calculations show that it's likely that the costs to produce MOX and make it available for reuse in reactors outweigh any benefits from an economic perspective that we can get from selling the plutonium or selling the MOX, really, rather, and getting some value back from that. But clearly through reuse we can release, as Bernard said, significant energy value from it, and it obviously displaces uranium fuels from reactor cycles, so there is some benefits there. Clearly we've already expended significant time, money and cost in separating out the plutonium through reprocessing over many, many years, and this is one way to try and get some value back from that by reusing it, hence why that's the current preference.
Does anyone want to?
Je voudrais dire, if I can move to French, je voudrais dire que les aspects économiques sont évidemment très importants et dans les études que nous avons lancées avec Areva et EDF, nous attachons à essayer d'évaluer l'impact économique des options. Et je voulais dire que c'est très difficile d'isoler telle ou telle opération, de vouloir connaître par exemple le coût de l'utilisation du plutonium sur les MOX. l'incidence économique du plutonium, elle arrive au moment où on s'en sert. Elle est dans les économies d'uranium que l'on n'utilise pas, dans les travaux d'enrichissement que l'on ne fait pas, et elle sera aussi dans le coût du stockage, du management et du stockage des déchets finaux où il n'y aura plus de plutonium. Et donc il est très important d'avoir cette approche de façon très globale. Voilà, c'était le message que je voulais délivrer.
So just to add to my other colleagues, just in terms of what they've said, in terms of actually looking at the costs and the value associated with a material such as plutonium, I believe it really does depend on the length of time frame that you're looking at in terms of the entirety of a fuel cycle, but also actually looking at the longevity of that material. Now, in some cases, people will look at that over one nuclear plant lifetime. In other cases, people might look at that over multi-cycle and actually looking at a much longer time frame, 100 years and beyond. And I think that you sometimes find that some countries maybe have different comparators in terms of the time frames being looked at, and therefore the energetic value associated with plutonium as an asset will be different depending on how you look at that.
Thank you, Fiona. To speak about the time frame you mentioned, I think that if there is to be this cooperation between France and the UK, one has to agree on one very simple definition. What is a sustainable fuel cycle? And why is this important? So I think it should be interesting, and especially Bernard defined the French view about this sustainability. What can you say about that?
I think this one's a very interesting question, and I think that it will mean many different things to many different people and also many different countries, depending on who you speak to. So here's my view of the world, just in terms of what I think a sustainable fuel cycle is, in terms of what we do in the UK anyway. So number one, it has to be a fuel cycle that enables economic value to be driven from it. And when I talk about economic value, I mean the totality of the fuel cycle. So the value from the overall fuel cycle. I think it also has to be one that deals with making sure it has the right environmental, safety and security constraints that have been taken into account. And for us in the UK, two other things. It has to be something that on the environmental side has to enable us to meet our carbon dioxide emissions reduction targets, in addition to enabling us to meet security of supply in terms of nuclear energy supply, which is a key component of the UK energy mix going forward.
If I may?
Yes,
just
please.
Yes. I think when it comes to sustainable, it does not mean we are expecting the final solution. And what happens in the US for me is something that I believe is a real danger for our industry. We are really in this issue in a step-by-step approach, and it's the case in most of the countries that developed nuclear on the longer term. It's the case for India, it's the case in China, it's the case in Japan, it was the case in France, and still the case. So what we want is really to show that there is a way. And the way relies on improving a certain number of fuel cycle processes, reactors, trying at the end to feed the reactors with the appropriate fuel that is the best to handle into the reactors and as a residue. Of course, there will be plenty of research around that, but waiting sustainable as a concept is just not the storyline we want. What we want is really to have something that improves the cycle in terms of risk management, in terms of, I would say, scarce assets to manage, and in terms of economics, basically, but on a term which is manageable by the utilities, because it's costly, and by the industry and the research and development centers. My fear that in 30 years from now, we will have difficulties because people do not want, in a certain number of countries, to go to this step-by-step approach.
Bernard, you wanted to add something, and then we will take a few questions from the audience.
Je voulais simplement dire que la notion de sustainability recouvre quelque chose de très large. On peut mettre l'économie, la sûreté. Le forum Génération 4 qui se préoccupait de savoir quels devaient être les critères qui permettraient de définir les meilleurs systèmes nucléaires pour demain avait identifié 3 grands critères, la sûreté, l'économie et la sustainability, qu'on peut appeler durabilité ou sustainabilité en français. Et dans cette sustainability, on y mettait l'utilisation rationnelle des ressources naturelles, ne pas gaspiller, quelque chose qui a une valeur énergétique, ça c'est le premier critère. Le deuxième critère, c'était de minimiser les déchets, pour minimiser l'impact à l'environnement et aussi pour adresser une question que certains appellent la ressource rare que constituera demain un site de stockage de déchets. C'est pas quelque chose qui est facile à obtenir. Je crois qu'on le voit en Europe, on le voit dans le monde également. Et elle y avait ajouté, je suis d'accord avec ça également, la résistance vis-à-vis des risques de prolifération, qui est une dimension qui apparaît également très importante si on souhaite un nucléaire durable.
Qui est aussi un domaine de coopération important entre la France et le Royaume-Uni. On va prendre quelques questions de la salle brièvement, si vous voulez bien vous présenter et être assez bref dans votre question. Merci.
Emmanuel Horowitz, EDF. Donc j'ai 2 questions. La première, on a beaucoup évoqué des synergies concernant le cycle ouvert, fermé, je dirais, et on a moins évoqué les synergies de cycle ouvert sur l'aval du cycle. Je parle des dépôts finales. Est-ce qu'il y a des synergies importantes dans ce domaine? Deuxièmement, j'ai été frappé que M. Boullis ait parlé du forum Génération 4 à l'imparfait. Est-ce que ça signifie que cet organisme international va avoir sa situation s'estomper ou est-ce que c'est un malentendu? Voilà.
Boullis, alors c'était de la concordance des temps.
La deuxième question. J'ai parlé imparfait parce que c'était la définition qu'ils avaient donnée au début du démarrage du forum, au début des années 2000. Je crois que depuis, la notion de sustainability, l'ont fait évoluer. Si je me trompe pas, ils ont retiré la résistance à la prolifération de la sustainability, mais c'est du détail. Mais il faut pas voir autre chose dans mon imparfait, sinon j'aurais des histoires. Voilà.
Voilà, qui est corrigé. Sur la première question, peut-être Dominique, Fiona.
I can start if you like. Yeah, yes. Concernant le cycle, la coopération sur le cycle ouvert ou cycle fermé. À partir du moment où on a 2 pays avec 2 politiques différentes aujourd'hui, on peut parfaitement imaginer qu'il y a un point commun. C'est quand même le comportement des combustibles usés sur le long terme. Donc rien ne nous empêcherait de faire de la recherche sur le comportement des gaines, des combustibles usés, etc. De telle manière, une fois de plus, les solutions qu'on a aujourd'hui ne sont pas les solutions définitives. Donc on a tout intérêt à développer des partenariats dans ce domaine-là, compte tenu des quantités de combustible qu'on a d'un côté de la Manche et de l'autre côté de la Manche. Néanmoins, moi je prêche pour un autre système. On a des électriciens qui vont être maintenant cross-frontières. C'est quand même bizarre qu'on n'arrive pas à donner de la liberté aux électriciens qui sont d'un côté du channel et de l'autre sur la politique qu'ils veulent mettre en œuvre en matière de combustible usé. Pourquoi? Parce que si je prends la nature des déchets associés, si je prends le Royaume-Uni, vous y trouvez des déchets vitrifiés et compactés et des combustibles usés. Qu'est-ce qui empêcherait British Energy finalement de décider que économiquement, elle peut avoir intérêt, et dans l'intérêt du Royaume-Uni, de continuer le recyclage en faisant par exemple du recyclage de combustible à la Hague et de l'entreposage de ces déchets sur un centre d'entreposage qui serait au Royaume-Uni, sous prétexte, bien évidemment, et sous la réserve que le Royaume-Uni accepte que ce genre de choses se fasse et que ce soit économique pour British Energy. Donc, moi, je pense que les règles doivent changer. Elles doivent donner, dans un cadre donné, la possibilité, dès l'instant où la régulation sur les déchets est claire dans le pays, la capacité aux électriciens de choisir ce qu'ils pensent être la meilleure solution. Mais c'est un point de vue industriel.
Thank you. I think that no matter what fuel cycle we end up going down, and of course in the UK we're moving to open, at least in the next decade anyway, there's still the aspect of management of spent fuel, as you say. So there's long-term behaviour aspects of that fuel within a storage environment, within a repository environment, and everything associated with that. There's the waste management constructs associated with all of the material that has come out of the reactor and how that's managed over time. Separately, even if we are, as we are going to be on an open fuel cycle for a while, we still have quite a lot of plutonium that needs to be dealt with. So whatever fuel cycle we're on, whether it's closed or open, we still have 140 tonnes of this stuff to actually deal with and manage, and that's going to take a few years anyway in terms of actually driving that forward. Finally, what I would say is that no matter what we can do together is actually understand how to best make use of scarce resources, whether that be understanding the issues with the repository in terms of volumetric capacity, radiological capacity, whether it be looking at what we need to do in terms of stores, in terms of fuel, whatever that may be, making best use of scarce resources, I think will be key, because at the end of the day, we're in an economic climate that's going to really drive that.
Thank you very much, Fiona. So we will conclude on this word. We could have spent another hour talking about especially the international dimension. Thank you very much to our speakers. Thank you.